Hello everyone, my name is Nilesh Kanate. Welcome back to my channel. In this video, I'm going to show you 5 essential kubectl commands that will help you solve 80% of the questions you face in the CKA exam. Most CKA candidates don't fail because they lack Kubernetes knowledge, but because they are too slow. Remember, you got 2 hours to solve 15 to 20 hands-on tasks. That means you hardly got 7 minutes to solve a question. So there is no time to overthink or pause. So you need to have imperative commands on your fingertips. You cannot afford to write YAML from the scratch. That is a time trap. Instead, you rely on these 5 commands that are not just useful, but they are the backbone of everything you do in the Kubernetes. It could be troubleshooting, RBAC, networking, cluster setup, cluster checks, everything, they come up everywhere. So let's dive in and see them in action. So our first go-to command is kubectl run. So this is the easiest way to create a pod. I mean, if you master this one command, you can spin up pods in seconds. In the exam, you'll be creating pods all the time. Most candidates waste their precious time writing either YAML from the scratch or copying YAML samples from the Kubernetes documentation. That is very slow and unnecessary. Instead, we use this command. So let's see that. Let me open my terminal. So here is my terminal. I'm using minikube as my Kubernetes cluster, minikube status. So that shows, so I have 2 worker nodes and 1 control plane node. So that is minikube MO2 and MO3 as the worker nodes and minikube as my control plane node. Now let me see kubectl. What is the command? I told you kubectl run. So use kubectl run nginx. So I'm creating an nginx pod with an image nginx -- restart is equal to never. By default it is set as always, so that's why I'm giving the flag as never. Now when I hit enter, it created pods in seconds. You don't need any Kubernetes documentation or to have to remember the YAML manifest. No need. It's simple and easy. So this creates pod name nginx which is using an nginx image. So this is an easy way to create a pod, as I said. Now, but there's one habit you must build, and it is one that decides if you pass or run out of time in the exam. So let me show you that. Now kubectl run, I'm using, so let me check the pod first, whether it said it created. Let me check the status. Kubectl get pods. See, I've created an nginx pod and that is in the running status. So now let me run another pod. I'll name it as nginx pod and I use again nginx image -- restart is equal to never, and then I use a flag called -- dry run is equal to client -o YAML, and I name it as nginx pod dot YAML, and I hit enter. Now let's see the magic. Now what happened? Let me see whether it created pods. No, it didn't create any pod. But what happened? Now when you use -- dry run as a flag, then that tells Kubernetes to generate a YAML without actually creating the pod. That's why we did not see any pod that is created. It did not create a pod. However, it generated a YAML for you. It gives you a perfectly formatted manifest just in seconds, just this one command, and you can open it and tweak it according to the question. Sometimes the question may be asked to add some environment variables or to add some labels. This is how you can do it. So let me see how do I open that? Vi nginx -pod dot YAML, hit enter. See, we have our nginx pod that has been created. This is perfectly formatted manifest. You don't have to go to any documentation. Just this command will help you create pods in seconds. It did not run the pod, just it created a YAML manifest for you. Now you can do some tweaks to it and then you can run it. So how do I run it? Let me run it and show you. Kubectl apply -f nginx pod dot yaml. Yes, the pod is created now. Let's see. Kubectl get pods. See, we got two pods that has been created. One is with a simple command and one is with the nginx pod, where we created a YAML file and then we created that pod. Now, so in the exam, if a question requires you to modify something and generate the YAML first, okay, and then if not, go directly, use imperative command and save yourself time. That's it. So let's see one more example. So what is that? I want you to create a pod that uses that name. You can name it as a Redis or and with an image Alpine. You can add labels and then we will set some environment variables. Let's see now. kubectl run. Let's name this as a Redis pod, Redis -pod, and I'm using an Redis Alpine image. This very small image. Redis Alpine, and now I want to add labels to it. How do I add labels? You have something called a labels flag. Now you use this and I use app equal to some, let's say, cache I'm using, and hyphen I'm going to add some environment variables. Env is equal to, let's say, max mem is equal to let's say 512 MB I'll give you, and now I'll hit enter. It says, oh, I misspelled it. It's labels, labels equal to app cache. Yes, it's created the pod now. Let's see, kubectl get pods. Can you see we have a Redis pod up and running? We added labels with just imperative commands, and we also added env environment variables. So if you want to see that, kubectl get pod Redis -pod -o YAML, sorry, kubectl. So that gives us the YAML formatted manifest. If you see, we added a name Redis, the label also added imperatively, and then we also added some env variables. That is max name is equal to maximum value is 512 MB. This is what we did. How we did it? We did it just with the imperative commands. So that's why these commands need to be on your fingertips. So that's it, just one line and no YAML files, and you have created everything that is asked in just seconds. Remember, in the CKA exam, speed and precision are everything. So this is our first command. What we learned kubectl run using a name of the pod that's using flags, different flags like -dry run in order to create a pod. In order to create a YAML manifest without actually creating a pod. It generates a YAML for you. -dry run is very much important. You keep using this in the exam all the time. I hope the first command is clear to you. Let's move to our second command, that is kubectl logs -previous. This is my personal favorite. Let us understand with an example. Let me open my terminal. Let me create a pod. Let's say kubectl run. Let me name it as a crash pod. Let me use the image Alpine and then enter. Let me print some message. Echo container starting, and then I use something called as non-exit code as non-exit code. Now, when I use a non-zero exit code, that means it's a failure. This pod should fail. I intentionally trying to fail this pod. If I hit enter, yes, it created a pod. let me see kubectl get pod -w. Let me watch how it's creating. See, if you notice, it entered the crash loop backoff state. Now, many candidates misunderstand a crash loop backoff as an error. However, it is actually the state of the container. It means the container has started, exited with a non-zero code, and Kubernetes is repeatedly trying to restart it. After several failed attempts, what it does is it enters a backoff state, and by gradually increasing the wait time between the restarts. So what's happening is the container failed, Kubernetes restarted it, it failed again. Now, before it restart, Kubernetes backs off and waits before the other restarts. So that's how it enters the crash loop backoff state. If you see, the first time it entered the crash loop backoff, and then it started the container, it was running, and immediately, it restarted it. So this is how it enters a crash loop backoff state. And if you see, there is a delay in the restarts. Before it restarts, it waits. That's how it enters the backoff state, and then it restarts it. It increases the time gradually, between the restarts. So that's how it enters the crash loop backoff state. It's a loop. So now let's see kubectl. I hope the concept of crash loop backoff is clear to you. Nothing but pod starts, crashes immediately, and Kubernetes automatically restarts it. So now kubectl logs. What is the name of the pod? Crash pod. It should print yes, container starting. And now if I use the hyphen previous, yes, it's printing the what it's printing. It's printing the message that has now the command we just use show the logs from the current running container. This is very important. It only shows the logs from the current running container, but it's if it is crashing too fast or hasn't written any logs yet, you get nothing because it's writing the it's writing something in the logs and then it's exiting. That's why you could see something here. So that's how it the previous previous flag helps you in the exam. So most candidates, they get stuck with this. If they don't see any logs, they get stuck and they think the logs are missing, or they waste time checking the wrong things. So you have to remember that the logs are from the current running container. But if the container is crashing too fast, or if it has not written a logs yet, you get nothing. So Kubernetes only has current logs. By default, it has only current logs, but not the previous logs. So when you use previous logs, the previous flag, this is when you can see uh, the logs from the crashed container. So previous only works if the container has stored logs from the previous crashed container. If the container restarts too quickly or has not restarted yet, Kubernetes has nothing to show. So it throws this error. So whenever in the exam you see a pod is in a crash loop back off or in an error or with a high restart count, your first go-to command for the troubleshooting is previous flag. So I hope it is clear to you. Let me show you the describe command and see the actual error. So pod, we have some named it as a crash pod, and then I'll try to filter it in A5, and then I use what's the, let's say it's a last state, I guess. Yeah, last state. And then you see the reason is error and the exit code is 1. Now you know what exactly need to be fixed. The exit code 1 confirms container exited intentionally. So you can go ahead and fix this now. How can we fix this? So we have already, yes, we created a pod. Instead of this, let me sleep to after the that is, let me use this, and then let me change the name of the pod because it's already exit. It throws the error otherwise. Let me hit enter. Yes, it created a pod. Let's see kubectl get pods. Now this should work. Pods -w. Let's see. Yes, it's running. So we have the container running. We know how to look for the logs. If the pod is crashing, if the container is crashing too fast, then wait to look for the logs. So we have to use the flag hyphen hyphen previous. So this is the go-to command for your troubleshooting when you see something like crash loop back off or error in the exam. I hope it was clear to you. Now let's clear the screen and move on to our next command, that is kubectl auth can. Now this is one of the most important commands, I would say. Before you run any command in Kubernetes, there is one question you should always ask. Am I even allowed to do this on this cluster? Am I allowed to create pods on the cluster? Am I allowed to list pods on the cluster or deployment services, anything? If you want to check whether you're allowed to do it or not, so this should be your go-to command, that is kubectl auth can. Kubernetes RBAC is like a security guard at the entrance of every action. Now, this command is like asking the guard if I'm allowed to do any particular action on the Kubernetes cluster. Now, this checks your current user permissions without actually performing that action. It doesn't perform that action, but gives you the answer either yes or no. Let's see with an example. If I say kubectl auth can I get pods, it says yes. Kubectl auth can I delete deployments? Is yes, yes, because I'm a cluster admin. Let me impersonate as some non-existing user. If I say John, it says no, because John has no such permission to perform this action. So let's say if I want to list deployments, can I? No, because there is no such role is assigned to John or to perform this action. So RBAC has basically three main parts. One is role, other is service account, and the third one is role binding. Now, what is role? It defines what actions are allowed. Uh, are you allowed to list the pods, deployments, service accounts, or you want to are you allowed to delete pods? Everything is mentioned, is defined in the role. Now what is service account? Now service account is nothing but defines who's trying to act. Now who's trying to perform that action is defines the service account. What about role binding? It's simple. It connects both who and what. It connects service accounts and role, and that's nothing but a role binding. When these works together, which is when you can perform any particular action for that particular user or per a particular service account. Let's see that in action now. So let me clear the screen. If I say kubectl, let me create a service account. Now let me name it as reader-essay. Let me create in some namespace. Let me name it as dev. Oh, because the namespace is not created. Create a namespace as dev. Yes, it created the namespace. Now let me run that command. Yes, it created a service account. Now let me create a role. We created a service account. Now we have to create a role that defines what actions are allowed. Create a role, and let me name the role as a reader role, and let me give get and list as these actions on what they can perform on what resource. Let me give it as pods. So on pods, and in which namespace? In dev namespace. So I created a role as well. kubectl. Now it's time to bind both role and the service account. How do we do that? We create role binding for that. So we create a role binding and we name it as a reader binding. And what you're binding? A role, that is reader hyphen role, and then you're binding a service account as well, service account, and it's in the dev namespace, and the name of it is reader hyphen essay, and in the namespace dev we are binding it. So we created three things, that is service account, role, and a role binding. Let's see if you are allowed to perform, can I get pods? It should give me yes as how service account dev namespace reader hyphen sa, and that's in dev namespace. Yes, because we gave the role as to get and list the pods. Now if I change it to deployments, let's see what it gives. It should give me no, because you're not allowed to perform this action on the cluster. Clear? Now this is how you create a role bindings and service account. Now let's see another example and understand for the user. So for that, let me set the config file to some credentials. That is kubectl config set credentials, and you use, let me name it as name as John hyphen username is equal to John hyphen password equal to pass. Yes, now John is set now. Now kubectl config that context, let me use it as a John context. We have to we use hyphen user is equal to John, and cluster is Kubernetes. Yes, John context is created. Now we have a user named John who needs access to the cluster. Let's attempt to list pods as John. Kubectl get pods hyphen as is equal to John. So it gives me error, forbidden. What do you mean by forbidden? It's restricted. Now this is what most candidates do. They try a command and get as soon as they get a formatted error, they start digging through YAML files. But there is a faster way to do it. That is nothing but our kubectl auth command. That is, can I list pods as, that is John. Now this gives me no. So what happened now? One word, just it gives only one word, that is no. John cannot list pods. Now let's see what he can do. kubectl auth can I create deployments as is equal to John. It says again no. Let's see if we can get the nodes. Kubectl auth can I get nodes as John? No. So it gave resource nodes is not a namespace scope. So what is namespace scope? Now this is Kubernetes telling you that nodes are at cluster level resources. The command still works, and we got no. Command cannot, no, I mean the John cannot view the nodes. So the resources that are namespace scoped are pods, deployments, services, your config file, and there are something that are cluster scope. It could be your nodes, persistent volumes, cluster role, namespaces. These are all cluster scope. Now let's grant user John some node permissions. Let's see how to do that. So how we do it? We create a cluster role binding, and then we try to bind them. Let's say create cluster role node viewer verb. He can only view, you can get and list the nodes. That's what the I'm giving the cluster level permissions to. That is resource. What resource I'm giving it to node. So I created a cluster role. Now kubectl, we need to bind them, right? Cluster role binding John node viewer, let me name it as, and then I give cluster role because we need to bind the cluster role, right? Cluster role node viewer, what's the name we gave? We gave this in a known viewer, and the user is John. So we created a cluster role binding. Now this command, if you see kubectl auth, can I get nodes as use as John? Yes. Did you see the difference? Before it was giving me no because we did not have any role or role bindings assigned to him. So that's why it was giving me no. Now, once we created a cluster role and cluster role binding to view on to get and list the nodes, he could able to do it. So let's say if we can delete the nodes, it should give no. Yes, of course. So this commands tell you exactly what you can and cannot do. It saves a lot of time, reduces your mistakes and helps you to validate RBAC instantly. So RBAC is one of the most tested topics on the CKA exam. I know this is pretty much confusing, but you have to deal with it. So next time when you see a forbidden error in Kubernetes, don't panic. Just ask Kubernetes using kubectl auth can I hope the command is clear to you. Now let's move to our next command, that is kubectl explain. What does it mean? No, what it does, it's a built-in API reference. Let's say you're in the middle of the CK exam and you need to add, let's say, a liveness probe to a pod. You know the concept, but what is the exact YAML syntax? Or is it a liveness probe with a capital P or a capital L, or it's a live probe, or it has HTTP get or HTTP hyphen small get? It's quite confusing, right? Sometimes we tend to forget the flow or the resources, how to or the fields that goes in the manifest. So in that case, you don't have to waste time, trying different combinations or trying to look that in the documentation. Here is the good news, there is a built-in documentation. That is what it says. Your built-in API reference. You don't need to look for uh, the Kubernetes documentation or look at the YAMLs to copy it and paste it on your, during the exam. So this command helps you to see everything. Let's see that in action. So if you see kubectl, let me clear the screen first so that kubectl explain pod, it gives all the fields in the pod: API version, kind, metadata, spec, and status, right? This is what we have. Now, let's say, you know, let's say you need to know what fields are available under spec. For that, you type again explain pod dot spec. So these are the fields available under the spec section. Can you see everything? It gives you everything. It You have a host name, host ID, containers. Of course, you have containers, right? Now, let's say what you have inside containers you want to see. Let's say again kubectl explain pod dot spec dot containers. It gives you everything. It gives you everything. This shows you the structure of the pod resource. Every field you can set here. You don't need to know what fields are available under spec section or the container section. Just use this command. You need to know how to configure. Let's say you need to know how to configure readiness probe. So how do you see? Again, same. You use this command spec.container dot, let's say, readiness probe, and you have the fields available here. See, you got HTTP get, initial delay seconds, period, seconds, everything. So this is how anytime you are unsure about YAML structure or field names or any available options, this the exam environment has some restrictions, what to use and not. You are allowed only Kubernetes documentation, but this command, the internal documentation, helps you always. So, so the, that is your go-to command when you forget anything in the exam or you want to add any fields to your pod. So I hope this is clear to you. You don't have to memorize anything, just kubectl explain. It will walk you through the exact structure of what you need. Now, let's see our last and the final command, that is kubectl get events. Let's say you want to see a pod that is stuck in a pending state and want to know what exactly caused the failure. Then you immediately use the command kubectl get events, right? So let me see, kubectl get events. Now, if you look at this, the most recent event appears at the top, but you know the rest are a bit mixed up. You have a different timestamps, all the events mixed up with the new ones, so it's quite messy and very much chaotic. Since it's a generators very less events, you don't find it so confusing, but for the events with a bigger list, that's very much confusing, which is when the output looks very random and chaotic, and you know you spend a lot of time trying to figure out the order of execution to find the exact cause of the failure. So now I'm going to show you a command that turns your chaos into clarity. This command shows exactly what happened to the resource in a proper order, I would say in a chronological order. So before that, I would like to show you that we have two kind of sorting options. One is dot last timestamp that shows when the event was last observed, when was last seen, and the other one is metadata dot creation timestamp shows when the event was first occurred. So, but when to use these two, let's say for debugging pod that's been restarting, I would say you can go ahead with the last timestamp, that is better. Or and if you want to understand the initial cause of failure, then you go ahead with metadata creation timestamp, that is very much better. So let me show you how to use that. So if you see kubectl get events hyphen hyphen sort by, that is equal to, let's say, dot last, I would use timestamp, last timestamp. Can you see? No, there is a clarity in it, right? So what happened first, what happened second, you see the order, the order of execution. The most recent one comes at the bottom. So Kubernetes events are not sorted by time by default. So, and which is why it's hard to understand the real cause of failure. So, so always remember, whenever you want to find anything that could be a pod crash or any failure, then you would first use kubectl get events with a sorting option. You can either use either of the sorting options and get your things fixed. When the cluster is very noisy with events, it filters out what exactly you need. That saves more time and it gives you clarity to understand uh, what went wrong, and you can get the pod fixed. So this is all about Kubernetes get events, and that's it. These are the 5 kubectl commands that will save your time, reduce your mistakes, and boost your confidence in the CKA exam.